All right, the last type of potential energy we'll talk about tonight is gravitational potential energy. And that is given by the equation potential energy equals mass times gravity times height. This potential energy equation is probably the one you'll use most often in physics. I rarely, myself, having done 4 years of college and 3 years of research, rarely use spring potential energy. But you need to know it. It will be on the AP exam. Gravitational potential energy is generally the really useful one in considering things in everyday life. So this is an object's mass multiplied by the pull gravity has on it, multiplied by how high it is. You do have to pay attention to units here. Mass should have the units of kilograms. Acceleration due to gravity is 9.81 newtons per kilogram. Height has the unit meters, and then energy will have the unit joules. You do have to make sure your height's in meters and your mass is in kilograms. Anything else, and you'll have to convert. All right, there's the equation, facts about it. Make sure you got those. Picture of a guy skydiving because he has a height right now above the ground. Therefore, he has a potential energy of his mass times the gravity on Earth times height. And now I got two examples for this kind of potential energy. In both of the examples I'm about to do, you're going to learn a nifty trick that when dealing with potential energy, you can put 0 or the origin wherever is most convenient. The exception being if I say, how much potential energy do I have at a height of 5 meters? And you say, well, assume 0 is at 5 meters, your potential energy is 0. You can't do that. But you can, however, say, well, let the ground be 0, and then let's measure your height from the ground. So you can put 0 wherever is most convenient. You just have to be clear where 0 is. And you'll see some problems as we go along where that really comes in handy. In fact, the next example will deal with that. All right. By how much does the gravitational potential energy of a 64 kilogram pole vaulter change if his center of mass rises about 4 meters during the jump? So we have our pole vaulter guy. That's a guy who jumps over a sand pit using a big pole. So he's got his pole. Potentially looks like a wand from Harry Potter. Expelliarmus. And then his wand flies out of his hand. Ha 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 ha. So he jumps about 4 meters high, and we're measuring from his center of mass, which is another thing you'll learn more about, but basically you could think about it as wherever his mass is centered. So around the center of his body, but not quite. So he jumps about 4 meters high. Think about it that way. Potential energy is calculated mass times gravity times height. Let's have the ground be 0. That, of course, makes sense. You wouldn't even need to declare it in this problem because that'd be obvious. Now we just plug in the numbers. Potential energy equals 64 kilograms times 9.81 newtons per kilogram times the height he jumps, 4.0 meters. And then you just multiply them out. Potential energy is potentially the easiest thing to calculate. And when I did 64 times 9.81 times 4, I get 2,511, and I rounded off there, joules. 2,511 joules as his change in potential energy. So he had 0 potential energy at the ground, and the question asks for his change in potential energy. When he gets up here, that's his new potential energy. If he started with 0, this is also his change. So that's how much potential energy he has. Just so you know, because you can set 0 anywhere, most questions will ask you for the change in potential energy, and that's just asking you to calculate the potential energy. So the people who design the AP exam know you can put 0 anywhere, and so they'll declare a starting point. Like here, your starting point was the ground. How much does this potential energy change from the ground? So because they said there was a change, you were expected to call the ground 0. And so you're going to see the word change a lot when dealing with potential energy. That's because the people writing the questions understand the 0 can go anywhere. So they're telling you where to put your 0. And you'll see that more in this next example. Example 3 for the night. A 1,000 kilogram roller coaster moves from point A to point B and then to point C. What is the change in potential energy from point A to point B? Okay. So this question, once again, I told you it's going to ask for change, and they're saying from A to B. When the question asks you from one place to another, it's telling you call that first place your 0, and then find the potential energy to wherever it gets to. So from the 0 to point B, the problem even has it labeled for me. That's 5 meters. So potential energy, and I'm going to try to fit both these on the same slide, so I'm going to label them. Potential energy from A to B is mass times gravity times height. We've set point A at a height of 0, and point B is 5 meters above that, so PE equals the mass of the roller coaster, 1,000 kilograms, times, let's go ahead and make it easy and say about 10 newtons per kilogram, times, oops, ran out of space, 5 meters, because I've set point A as 0, and point B is 5 meters above that. So 1,000 times 10 is 10,000, times 5 is 50,000, so my potential energy is about 50,000 joules. And for those of you keeping score at home, if you use 9.81, you got 49,050 joules from A to B. Okay, now let's look at the next part. What is the change from B to C? Okay, well, change from B to C, let's make it really tricky. Let's now call B 0, and let me color code because I'm doing a different problem. So let's call B 0. That means the height at C is negative 15 meters, right? Because we're below the 0, so my height would be negative 15 meters. Potential energy equals mass times gravity times height. Potential energy is 1,000 kilograms times 10 newtons per kilogram times negative 15 meters. Mr. Melvin, I thought you said we didn't need to worry about the negatives. Well, generally you don't. However, you can clearly see that if you go from up here to down here, your potential energy decreases. So why not go ahead and include in the problem, hey, that's a decrease, it goes down. 1,000 times 10 is 10,000, times 15 is 15,000, and like I said, we know it's going down, we know it's negative. Let's just go ahead and say it, negative 15,000 joules. Okay, now it became negative because I set B, the first point the problem gave me, at 0. So I called B 0, and then from B, which is 0, to C was down 15 meters, negative 15 meters, and multiplied out about negative 15,000 joules. The change was negative because you had more potential to fall at the top than you did at the bottom, so you lost some potential to fall. All right, hopefully the negative didn't throw off anybody. It's very clear in that diagram. Hey, it's going down. Make it negative. Why not? Call it what it is. Just like with the two masses on the pulley, you know one of them is going down. Why not just go ahead and say it? You know that thing's going down. Why not just go ahead and make it negative? Okay, so key points to take away. When a problem gives you 2 points, you always set the first one at 0, and that usually makes things easiest. So the first time it said from A to B, I called point A 0. Second time it said from B to C, I called point B 0. Potential energy can have a 0 anywhere, and the people who ask questions are usually smart enough to know that, and they say, we need to give them a starting point, otherwise they can just put 0 anywhere. So they give you the starting point of A to B, and then starting point of B to C. All right, we'll talk more about that tomorrow. I'll be happy to answer questions if you're confused about the starting point. And that's it. Have a good night.